Warm greetings from Jaya School of Architecture. I welcome you all for the session 13 of the successful DECODE series. Today, we are going to discuss on a very interesting topic, simple architectural hacks for budget optimization of smaller projects by architect Ar.Ezhilmaran.
Simple hacks, for budget optimization of smaller projects. Now, why should we look at budget optimization of smaller projects, and why not for larger projects? Okay, larger projects is a completely different ballgame, and let us not deal with it at the moment. So, what do we mean by smaller projects? Smaller projects may be costing less than about a crore at the moment, but in today's time frame, may be called as smaller projects. And can you look at this picture image on the screen? Okay.
Yes, sir.
Okay, fine. Thank you. So I would like the students to come forward and either speak up and share their views about the presentation while it is going on. Now, this is called as Vitruvius Man. I'm sure you would have learned about Vitruvius Man in your history of architecture or theory of architecture. Now, who is this Vitruvius Man? This is Vitruvius Man was proposed by Vitruvius. He wrote a treatise of 10 books on architecture. It's called Des Architectura, in which he has told us about firmitas, utilitas, and venustas. Okay, now what is firmitas, what is utilitas, and what is venustas? He says, Vitruvius says that a building should be firm, a building should be utilitarian, and a building should be beautiful. Okay, that is what he has written in his book, This Architectura, a treatise on architecture. Now, if he had lived, he would have added one more point. Economitas. I'm not sure if there's a word called economitas in Greek, but I'm just finding a word like this for this session. So, what is economitas? And why should a cost of a project be controlled? Now, let us look at the broader picture now. See, buildings consume about 40% of the total power that is generated. Okay, so which means we are still largely depending on thermal power plants. So every unit of power consumed means coal burned and the environment polluted. And also take a look at the raw material usage. Very high raw material usage is leading to overexploitation of available resources. And we have very, very limited skilled manpower. So again, this boils down to a situation wherein we'll have to tone down our requirements and we'll have to frugally use our resources, available resources. Okay, now take this project for example. We have recently submitted a feasibility report for this project. See, this is a project in Chennai proposed to be built on a 2-ground plot measuring 18 meters by 24 meters and abutting a 9-meter road. Now, students and fellow architects, now if you look at this site a little closely, you'll understand that CMDA is giving us 3 options for development. One is a stilt plus 3 structure, other one is a stilt plus 4, and another one is a stilt plus 5. We have 3 options. Which one among the 3 is going to be the least expensive option? Now, we did a small math, okay, and we found that, look at the first option, we were looking at a stilt plus 3 structure. And the total area, including the stilt, turned out to be 1152 square meters. And the second option, which is a stilt plus 4, the total area turned out to be 1080 square meters. Now look at it closely, you will find that the total built-up area, including the stilt 4, for the same 864 built-up area, maximum built-up area, is getting reduced by about 72 square meters. Why? Because the building footprint is lesser in the case of a stilt plus 4 building when compared to a stilt plus 3 building. Now let us look at the last option, which is a stilt plus 5 option. The same maximum built-up area of 864 square meters. The total built-up area, including the stilt floor, is 1036.8 square meters. Let's say 1036, which is straight away 116 square meters lesser than the first option. Now, the going construction rate for stilt floor, let's say, is about 20,000 rupees per square meters. So 116 into 20,000 square meters, 20,000 rupees works out to roughly about 22 lakhs. And what is the additional expense in foundation or taking the lift to a further 2 floors? It is probably about 5 or 6 lakhs. So there is a savings of about 16 to 17 lakhs in a project. So we have to figure out which is the best option when it comes to the building footprint. Lesser the building footprint, more the open area. More the open area, more lighting, and better ventilation for the project. And now look at this window area. I mean, most of us would think, what is there in a window area? What is there in a simple, humble wooden window or a UPVC or aluminum window? Now look at this 1.2 by 1.2 square meters window. The total area is 1.44 square meters. The glass area is 0.76 and the wood area is 0.68. And the ratio of glass to wood is 53:47. Take a look at that 5 feet window, the 1.5 meter window. The total area of the window is actually 1.8 square meters, and the glass area is 0.85. Wood area is 0.95, and the glass to wood ratio is actually 47:53. The ratio is actually reversed. Not only the glass area has become substantially lesser, okay, the wood area has increased, thereby increasing the cost of manufacture of this window. Okay, so what happens is we spend more and we get less light. Okay, so when we spend more, we are supposed to get more light. The efficiency of the window is supposed to go up, whereas now this is coming down. So we should design the windows in such a way that the glass area is optimally utilized. Okay, and similarly, air conditioning. A higher ceiling is going to end up in higher power bills, whereas lower ceiling might not look very attractive for an interior. So it has to be controlled at an optimum height to make sure that the power bills don't go up. At the same time, the interiors also look attractive. Now take a look at this kitchen layout. Now, this project, the one on the left side is 1.8 meters by 3 meters, which is 5.4 square meters. And the one on the right, actually it is a 5.4 square meters window, 5.4 square meters kitchen, but the dimension are slightly lesser. It is 2.25 by 2.4. 2.25 by 2.4, the same 5.4. And on the one on the left is 1.8 by 3, which is again 5.4. But the running length of the counter varies. For the same given area, the rectangular kitchen offers only 4.8 meters of running length of kitchen counter, but whereas a square kitchen offers 5.1 meters of kitchen counter, which is more efficient. And take a look at this underground sump. Now, all these things are nothing but simple geometry. Okay, now that is why I call them hacks. Okay, and now take a look at the sump. Now, this sump, both the sumps, or the one on the left and one on the right, both of them have the same capacity, 12,000 liters. But take a look at the one on the left. Okay, the rectangular profile is the sump in plan, and right next to it is the sump in section, and the square one on the right is the plan of the square sump, and on the right it's section. Now the same 12,000 liters, okay, the cubic meters the concrete cubic meter is actually different. The one on the left is 2.375, the one on the right is 2.365. So you see there is a difference, and we have only taken the wall into consideration, and we have not taken the floor and the slab into consideration because it will vary from project to project. So including that, what happens is the rectangular sum will consume more concrete and more steel, making it more expensive. The square sum is less expensive with lesser building materials. Not only that, the square sum will have lesser shear stress and also lesser thrust from the underground soil. But a rectangular sum, because it has got two longer walls, the thrust due to the underground earth will be very, very high. Okay, now we all would have come across bricks. I mean, none of us would have missed bricks in our life. So the clay bricks is the most often seen building material, and now it is slowly getting replaced by fly ash bricks. And the other building materials these days are AAC blocks, solid blocks, and Porothan. Now, it might look as if all these things make no difference, or the clay is the most suited building material for us. But actually, clay is the least preferred building material when we do a proper comparison with other building materials. Like clay brick is made from clay, river sand, lime, and other materials. Whereas a fly ash brick is made from the fly ash that is disposed of by the thermal power plants as a byproduct. So something that is lying as a byproduct is being used as a building material, which is a good, which is a very, very positive sign. And AAC blocks, which was invented sometime in 1924, is a very, very lightweight concrete block which will float on water. That is the beauty of AAC blocks. The density is actually less than 1, and it can float on water. Solid block is slightly heavier, but then it is not as bad as the clay brick, but then not as good as the AAC block. It is cheaper. And Porothan, most of us would have seen Porothan, and if someone wants to see Porothan, Kottapuram Anna Boys Hostel, you can see Porothan blocks. So it is again made from clay. It is actually exploitation of clay because in India, as of today, only one plant is there, and it is operating from Bangalore. And we are overusing clay. So my personal choice would be AAC blocks. Why? Look at that fourth row, cost per m cube. Okay, cost per m cube, AAC block is the least, 3,400 per m cube, and the bricks are the highest. And the finishes, AAC block is really good. And we all know that every brickwork needs to be plastered on both sides. Okay, for that matter, any of the materials that we saw in the previous slide needs to be plastered on both the sides. Whereas AAC block is an exemption. What happens is you just have to do 2 to 3 mm thickness of gypsum plaster on the inside if there is no water-related application in that room. I mean, if it is not a toilet, if it's not a kitchen, then you can definitely do it with gypsum plaster, and it reduces the wall thickness, and it reduces the expense, it reduces the construction cost also. These are the Porothan bricks. Okay, now coming to plywood. See, plywoods are nothing but layers of ply stacked one on top of the other in that direction. And there are several grades of plywood: commercial plywood, boiling water resistant, boiling water proof, and so on. Now, of which boiling water proof is the topmost when it comes to quality, and it is categorized under IS 710. Now, while it might look like 16 mm is less stronger than 18 mm BWR, the BWR is the next grade of plywood. What happens is, when you take a closer look at the BWP chemical composition and the process of manufacturing, we find that a 16 mm BWP is more stronger than 18 mm BWR, and it is also less expensive than 18 mm BWR. So we normally prefer a 16 BWP instead of a 18 BWR. Now let's take a look at this grill designs. Now, see, grills are essentially meant for the safety. And while, an intricate grill design offers a lot of aesthetics, end of the day, what happens is the maintenance is expensive, the manufacturing cost is very expensive, and the painting cost, everything is very, very expensive when you compare it with the normal, simple grill design. So what we can do is, what I would suggest is, let us stick to a normal, simple grill design, simple geometry, horizontals and verticals, okay, which is easy to maintain. You want to dust the grill? Yes, it is easy. You want to paint it? Yes, it is easy. You want any sort of maintenance is actually easy. When you compare it with the intricately complex, detailed grill. So let us look at this. Let us do a comparison when we are designing a grill, and let us try to optimize the cost as much as possible, not only for today, but on the longer run also. Cement. What is there in a cement? Now, most of us would have seen that Ultratech cement ad. Every 5 minutes it flashes on the TV screen, and someone builds a house adjacent to a railway track, and then there is a vibration, and the son suggests his dad to use Ultratech cement, and the building is so strong, firm, whatever. I mean, it is. And every time I look at that ad, I laugh my heart out, because there is actually nothing in the cement. There is a lot of engineering that has to go into it, and a little bit of architecture also when it comes to the structural stability of a building. Okay, but here I would like to point out that there are two types of cement that are predominantly used, and there's a third one also. It's called GGBS, ground granulated blast furnace slag, which is not often used, which is not often sold also. See, among the two, PPC is actually cheaper. Every bag of PPC is actually cheaper by about 10 rupees, and the ultimate setting strength is higher in PPC. That's the beauty of PPC. But whereas most of the traders, they will want to sell OPC. Most of the cement manufacturers, they will want to sell only OPC. Most of them might not sell PPC, but it is our responsibility to have a word with the structural consultant and our client, take them into confidence, tell them that a PPC is actually better for the project, and let us go ahead and use PPC. And not only PPC is cheaper, I'm not suggesting PPC because it is cheaper or it has got a greater ultimate setting strength, but it is also a green building material, or rather more greener than OPC, because it has got a blend of 33 to 35% of fly ash. Okay, this is a comparison of OPC and PPC. Well, this is another thing that we'll have to take a closer look. See, basement, we have seen basements in malls, theaters, hotels, and in many other places. Now, which is better for parking of cars? I mean, if there is a limited number of cars, still it is much better option when compared with basement. Why? Let's say the cost of construction of stilt in today's context is 20,000 rupees per square meter. But the cost of construction of a basement floor is actually much higher, at least 1.6 times the construction cost of a stilt. Okay, so which means at least 32,000 rupees per square meter for the construction of a basement. And basement, we have lots of water seepage problems. Every time a basement is built, we'll have to do waterproofing from the positive side, which is the side which has got contact with the earth. It's a very tedious process, and it has to be maintained. And there is a lot of power that spent on air circulation inside the basement. Exhaust fans have to be in place, and they'll have to work cyclically to extract the stale air. So these are problems in basements, and the deeper you go, the higher you spend. So if possible, let us stick to just till floors, and as much as possible, take the additional parking that is required to the higher floors. CMDA these days they are giving us a rebate on the height of the building if you are taking the parking to a higher level. Please read the CMDA document and you'll understand. Now take a look at this housing layout. See, the one in the middle is the normal layout, okay? 6 by 18 and 9 by 12. Both of them have the same area, which is 108 square meters, okay? Now, but among the two, which is more suited? Actually, while most of us will say 9 by 12 is the most suited in a housing layout point of view, a 6 by 18 option is more suitable. The reason is now the roads are shared by, the half the road is shared by the plots on the same that side. So which means a 9 by 12 plot shares half the road, and it's got a slightly higher area of 135 square meters, whereas an 6 by 18 shares half the road and it consumes lesser, which is 126 square meters. So there is a saving of about 9 square meters. So if possible, let us do linear plots. I mean, let them not be so linear, but at the same time, let us make sure that they are not, the length is greater than the breadth, that the breadth be greater than the length. That way we'll have a more economical plot in a housing layout. Okay, the picture in the middle, I shot it today from a government hospital warehouse in Ananagar. Okay, now they have tried to clad the column using granite. But what has happened is, over a period of time, the granite has fallen off, exposing a portion of the column. Okay, now what am I trying to convey here? Now, should we really clad these columns with granite? Don't we have other options? Okay, yes, we have other options. We can actually polish the surface of concrete. If you can see the picture in the middle, it is a concrete column which is being polished by a concrete polisher. Look at the right picture, you see a polished surface. Now, this is actually very interesting. Now, I'll go back to the previous picture. Take a look at the column at the center. Now, let us imagine that there is no granite cladding done there. Instead, we are polishing the entire column from top to bottom. So we'll have a mirror finish, completely unique concrete polished surface with no granite. Because why am I trying to avoid granite? Am I averse to granite? No, I'm not at all very averse to granite. I love granite, but should we overuse granite? Every time granite has to be brought to a site, it is quarried in some place, it is blasted, and it is cut to size, and then again it is shipped through a container, lorry or something. And here they use a gang saw, and the rock that is quarried, hardly about 70% is utilized. Balance 30% is actually going as waste. So for that reason, I would prefer to use these resources frugally. Okay, so what do I mean? I have a polished granite surface. I can use granite for the capital and for the base. I leave alone the central shaft. Okay, I'll polish the central shaft. I'll use a 0.5 meters or 1 meter capital at the top and another 0.3 or 0.4 base at the bottom. That way, I'm minimizing the use of granite in my project. I think this is the last slide I've got. I'm not sparing landscaping also. See, this is again a picture that I shot today. The one on the left, it's the Tirumangalam flyover column. Okay, they have tried to do a vertical wall, vertical garden, And it looked so well, so nice before about 3-4 months when it was initiated, but now it has lost its sheen. All the plants are withered away. Only the plastic pockets are lying there, fixed to the wall. Now, should we try all these gimmicks? What is the cost? It is roughly about 3,000 rupees per square meter. At such a premium price, should we be doing all these things? Why not have a simple creeper? I mean, there are so many creepers known to us. An ivy, maybe. It comes out with beautiful flowers. Let us try such landscaping. There are many many plants that grow under shade. We'll try them out. It costs nothing. I mean, most of the native species, it is maintenance free. The exotic species, so much of maintenance is involved. So let us try our native species and let us keep it very simple and frugal. And a big thank you to one and all for patiently listening to this presentation. I humbly request you all to raise a question or two.
So thank you for the session, sir. We do have a question in the chat box. What is the cost of polishing concrete?
Roughly about 600 to 700 per square meter.
Okay. So I hope Nicholas has got the answer. It is around 600 to 700
per square meter.
Okay. So any other questions? The participants are requested to post in the chat box.
And not only columns, but also concrete walls can be polished, floors can be polished, beams, ceilings, any concrete face can be polished. And the most interesting part is you can actually add color pigment while you're doing the concreting. And like if you're using a green color pigment, now it will actually look like a granite when you do the polishing.
Okay. Thank you, sir. Any other questions?
I think there is one more.
I think it's...
PPC is better than OPC, but does it compromise on the strengths? So just minor variation. Okay, let me cut a long story short. OPC is ordinary Portland cement. PPC is Portland pozzolana cement. What happens is OPC is manufactured using 100% raw materials, lime, sand, and other materials. OPC is nothing but PPC plus 33% of fly ash. Very simple. Okay, is there a compromise on the strength? No. See, this fly ash that we are using in OPC, in PPC, is extracted from, is a byproduct from thermal power stations. We know this fly ash for long. The name pozzolana in PPC is nothing but fly ash, the volcanic ash. Most of the Roman structures used volcanic ash for their strength. Okay, concrete was there even 2000 years before, and the same equivalent of volcanic ash, that is the pozzolana from thermal power station, is being used in PPC. It has been found that the initial setting strength that is checked in 7 days is lesser, but then 14, 21, and 28 days, the strength is very high when compared to OPC. So don't bother, there is no compromise. You can definitely use.
I can add there too. It helps in workability, especially when you're doing things like plastering. When you use OPC, you can develop cracks and hairline cracks happen. So in the real world, in certain areas, PPC is an advantage also.
Absolutely right. Because of the slow setting time.
So we have one more question. How good and feasible these low-cost material will support the contemporary electrical and plumbing service materials? You want me to repeat again, sir?
Please, ma'am.
Yeah. How good and feasible are these low-cost material will support the contemporary electrical and plumbing service materials?
Actually, none of them that I've spoken about is actually low cost. Can the student or the person be clear about which particular item? Okay, assuming he is asking me about AAC blocks or Porothom. It is actually, first of all, not a low-cost option. It is a cost-effective option. Okay, we are actually, when we are using bricks, we are paying high because we have got accustomed to bricks, for so many thousands of years. We want to stick to bricks as a building material. Actually, it is high time we abandon the use of bricks, right? And AAC has no problem in concealed electrical or plumbing. We have been doing so many projects, and not us. AAC is almost 100 years old product, and it has been used world over. Porotham is also being used world over. There has been no complaints with respect to electrical or plumbing. It is the poor workmanship that spoils the show. Otherwise, it's a very high quality building material.
So we have one more question.
Yes, ma'am.
Are narrow plots really a better option than the regular rectangular plots? What would be the difference?
See, in narrower plots, when you do a building, actually you get lighting from both the directions, and the penetration of light is actually higher. But in a conventional rectangular plot, you don't have a problem. But the plot, if it is a square, then you have a problem. The penetration of light may not be sufficient for the rooms at the center. So we would prefer a rectangular plot. Actually, the narrower plot that I've shown in this PPT, I would like you all to interpret in a slightly different way. See, compare it with a square plot and a rectangular plot. Rather than a rectangular and a narrower plot, please compare it with a square plot and a rectangular plot, where the frontage is higher for a square plot and the frontage is lesser for a rectangular plot. The lesser the frontage, better the efficiency of the housing layout, better the efficiency of the roads. That is what I try to convey.
To add to this, this narrow decision, because I had been involved in a housing project like this, what we added as architects is you can add the orientation factor.
Yes.
That it actually works because when the person sells a car, he has to factor the common area, the roads. So when that is minimized, so it becomes very feasible for them when they're doing a housing project. So as an architect, when you add the orientation factor to that decision, it becomes even more better, because when the longer portion is aligned along the north and the south, it becomes an advantage. The site becomes an advantage.
Yes, of course, very true. Orientation is a very, very important factor. But in this presentation, I have actually tried maximum to focus more on simple geometry, rather than more complex factors that govern the cost. More simple, like the rectangular and the square sum, or the kitchen layout, things like that. These things often go unnoticed when you're in a design. We may not be able to figure out which is the most efficient part, but then subconsciously we'll tend to lose out to these smaller things. So that is what I wanted to highlight.
So we have one last question. I think we have two questions. I'm sorry, too many questions for today. Okay, going with AAC bricks with high-end workmanship, will it increase the cost of the construction?
No, it is going to bring down the cost of construction substantially. I really mean what I say, substantially. The reason is, see, the size of a normal conventional brick is 230 mm by 110 by 70 mm. And the size of a AAC brick is 600 by 200 by 200. So which means it is equivalent to 12 bricks. Okay, it is equivalent to 12 bricks. So now please do a quick math and figure out how much of cement and mortar is required within the 12 blocks, 12 bricks. Okay. Now all the cement and mortar is actually completely eliminated, and you have one single block, right? That is one. And secondly, if you go to a construction site, you will see a sittal, a female coolie, a woman coolie, putting in so much of effort to carry that 9 or 10 bricks on her head to take it from one floor to another. But whereas this AAC block, which is equal to almost 12 bricks, can be carried with ease, so much of ease, because the density is so less, it can be carried with ease. The effort is actually much lesser, and the strength, the compressor strength is actually higher. So any aspect, it's a win-win for AAC blocks. So we will very strongly recommend replacing clay bricks with AAC blocks. There is no compromise.
Sir, but how is it? How is the thermal factor in Chennai for these fly ash?
That's a wonderful question. I was actually expecting this because clay bricks has got. It is believed that it has got the thermal insulation properties. But what happens is, the moment we plaster the brick with cement mortar on both the sides, we sort of laminate it like how we laminate an ID card. There is no room for the air to move in or move out. So that air exchange concept is completely gone. I mean, if you're using lime and sand for plaster, yes, it works. The clay brick, it works. Like an earthen pot, it works. It breathes. But cement mortar on both the sides, it completely arrests the airflow, and it will not allow the wall to breathe. So here, only one factor will play, and that is the I forgot the name. Just a moment. Thermal density.
Induction.
Or something like that.
Induction?
Not induction. Mass. Thermal mass. I'm sorry. Thermal mass. So what is thermal mass? Higher the density of the building material, better the insulation. We would have seen the stone bricks, stone blocks do wonders. It will be scorching summer, and inside a stone house, it will be pleasant, because the stone absorbs the heat, retains it for as much as possible, and then it leaves it out during the night. And similarly, during the night, it receives it loses heat, and it repeats the cycle the next day. So higher the thermal mass, better the thermal insulation. But here again, AAC block loses it to the bricks, clay bricks. I agree. AAC block, it loses it out to the bricks. But porotherm blocks, they win hands down. And fly ash bricks, or the solid blocks, concrete solid blocks, they again win hands down when it is competing with clay bricks. So again, we have a very clear reason why we should shun the use of clay bricks as early as possible. I'll tell you something. Clay bricks, we require clay, sand, and other binding materials for the manufacture of clay bricks. Even today, clay bricks industry is not a very organized industry. Child labor is involved, and the payments for the workers is not at all in line with any of the pay commission recognition. And furnace oil is used for burning of the kiln. Okay, and every time a brick is made, we release so much of CO2 and NO2 and NO and CO, so many volatile organic compounds and greenhouse gases into the atmosphere. So whereas fly ash bricks, it is only sun-dried. You put it in a mold, you take it, and then you just leave it under the sun. No kiln is required, no furnace oil is required, no burning is required. So in any case, all the other building materials other than clay bricks are greener than the clay brick. So we don't have to bother about that thermal comfort. We'll somehow offset it by other measures.
Thank you, sir. Thank you for answering all the questions. I now request our Dean to deliver the vote of thanks, a few words for the guest speaker for the day.
Thank you very much, Professor Kavita. A very, very big thanks to Architect Ar.Ezhilmaran. It was a very informative session, most wanted by the people who are practicing, and those from the field will know how much of worth your words carry. And I'm very sure this will have a lot of value for the young aspiring architects who are just about to come out and step out of college. And I'm sure that many of them, some of them have also already ventured into small projects and must be learning these nuances and the tips that you have given is very essential for their life-saving, professional skill itself. Thank you so very much. It's a wonderful topic which you have presented, very unique, put together very well. Totally appreciate what you shared with us, sir. We are honored to have you on our show, and we will interact further and collaborate further to do much more and many more events like this. Thank you very much, sir. And I thank all the audience who have joined today. I know that we had given you a very short notice, but nevertheless, please keep this time free for us. We will definitely come to you Monday to Friday through the month of February, sharp 6:30 to 7. Today is a little longer. Bear with us, but we will keep in time. Thank you.